Solving logarithmic equations. So I'm going to show you a couple different ways of solving a logarithmic equation. So first of all, let's look at example 1. We're trying to solve for x. And so the very first thing we're going to do, like we do with any equation, is we want to isolate the x by undoing GEMDOS. So we're going to start by undoing our adding and subtracting first. So we're going to start by adding 6 on both sides of the equation. And then we're going to undo multiplication by dividing. Okay, so now at this point, we have a couple options. So if possible, one option is to make the bases the same. So I'm going to go ahead and look at my base table and see if I can change 64 to base 4. So looking at my base 4 on my base table or my power table, here's 64. So I know that 4 to the third power is 64. So I can go ahead and change 64, rewrite it as 4 to the third power. And then at this point, since my bases are the same, we can cancel those out and we get an answer of x equals 3. So that's one method. This method does not always work. It only works when you can make the bases the same. Okay, so another method, if you can't make the bases the same, is to go through these same steps, okay? And then what you want to do when you get here, if you can't make the bases the same, is let's rewrite the equation, is you want to take the log of both sides. And then using the power property, we're going to move that x down front. Now notice both of these logs are in base 10. And since we're multiplying x times log 4, we're just going to go ahead and divide by log 4 on both sides. And in this case, we would want to use our calculator. And we're going to press control, and it's 10 to the x power. It's this button right here. It's got the log on it. All right, since we're in base 10, you can put a 10 in that spot, but you don't have to. And we're going to do the log of 64 divided by the log of 4. Oh, not down there. It's base 10, remember? And we get our answer of 3. Okay, moving along to example 2. Starting us off, we're going to undo the subtraction with addition. Okay, so there's nothing being multiplied out front. All we have is a base and the exponent. So at this point, we're going to, it looks like we can make the bases the same. So let's do it both ways. Let's make the bases the same and let's solve it using logs. So making the bases the same. If you don't know how to change 27 to base 3, again, I suggest looking at your power table. Base 3, 27, so it's going to be 3 to the third power. And that's equivalent to 27. Now that the bases are the same, we can go ahead and set the exponents equal to each other and then solve for x. Okay, now let's solve this using logs. So let's rewrite the equation from here, because this is where we would start applying the logs, never up here. As long as there's adding and subtracting or multiplying and dividing to undo, you cannot apply the logs property yet to each side. So let's log both sides. Now we're going to apply the power property, move that quantity, that group. We're going to move that down front, and I'm going to use grouping symbols because there are two terms here. This is multiplication. Remember, we want to isolate the x, so we're going to undo multiplication with division. So we end up with x plus 1 equals, and let me get out our handy dandy calculator. All right, so we have the log, and just so that you can see, you can put the 10 in there if it makes you feel better. Divided by the log of 7, I'm sorry, log of 3. Okay, and so we get 3, and subtract 1 on both sides, x equals 2. And since the domain for an exponential function is all real numbers, that means we won't have any extraneous solutions. So you don't have to check for extraneous solutions, but it wouldn't hurt to check your answer by plugging it back in and seeing if it works. So let's do that. Let's plug 2 back in. So we have 3 to the 2 plus 1 power minus 7. Does that equal 20? So 2 plus 1 is 3. 3 to the third power is 27. And as you can see, it checks out. Okay, if you have any questions, please bring your questions to class or email me, Elliot, if you have any questions. Thank you.